In this video, we are going to look at number 69. Here we have a polynomial that is in factored form, and we are going to do the following. We're going to find and list each real zero and its multiplicity. We're going to determine whether the graph crosses or touches the x-axis at each x-intercept. We're going to determine the maximum number of turning points on the graph, and then determine the end behavior of the graph. Let's get started. First, we are going to find all the zeros of this polynomial. When it's in factored form, that is very simple. It's especially simple if we have a problem that looks like number 64, where you have one of the factors is just x minus a number or x plus a number. It's a little bit more complicated when you have something like this where 2x squared plus 9, it's not as easy to figure out what the zero is here, but it's also not too difficult. What do we do? All right, so we'll start with this factor, 2x squared plus 9. So this function will be equal to 0 if 2x squared plus 9 is equal to 0. That's one way that this f of x could be equal to 0. So we're going to set that factor equal to 0, and we're going to solve for x. First, I subtract 9 from both sides. I get 2x squared equals negative 9. I'm going to divide by 2. I end up with x squared equals negative 9/2, and I take the square root of both sides. Now, looking at this, we do have two zeros. This could be simplified, but we're going to skip that for now because it's unnecessary for this problem. We have the zero. You could have positive square root. You could have the positive square root of negative 9/2, and you could have the negative square root of negative 9/2. In both situations, we are taking the square root of a negative number, which means that that would not be a real number. So this is a zero, but is not a real zero. And this problem asks to only list the real zeros, and we don't have any, or we don't, at least here, we've only found two complex zeros. We have not found any real zeros. All right, so let's go to the next factor. X squared plus 7 is equal to 0. If x squared plus 7 is equal to 0, then that means f of x will be equal to 0. So again, we're going to solve. X squared equals negative 7, and I take the square root. Again, we end up finding two zeros, but we're taking the square root of a negative number. That solution is not, there are no real numbers that are equal to the square root of a negative number. These are not real zeros. We did find two complex zeros, positive square root of negative 7 and the negative square root of negative 7, which we'd probably call plus or minus 7 times I, but these are not real numbers. So this part A of this question asks us to find all the real zeros, but there are no real zeros. So let's write that as a full sentence. F of x has no real zeros. And I think that would be a perfectly good answer to this question. Let's look at part B. We're going to determine whether the graph crosses or touches the x-axis at each x-intercept. Now remember, the x-intercepts are the same as the zeros. Since f of x has no real zeros, f of x also has no x-intercepts. So this question I can't answer. It's saying at each x-intercept, does it cross or touch the x-axis? It's really none of the above because f of x has no x-intercepts. All right, so that's part A and part B. Part C we'll do off to the side. And for part C and part D, it helps to find the leading term of f of x. And there are a couple ways you could do this. You could, of course, just multiply out the factors. You could square 2x squared plus 9 and then multiply that by x squared plus 7, then multiply that by 1/2. But that is overly complicated, and we can make our life a lot easier if we do a quick shortcut that I will show you. The way I find the leading coefficient, because we don't need everything, we just need the leading coefficient. And all we have to do this is this. Every factor, I multiply the leading coefficient of that factor. And if there is an exponent on that factor, I raise that leading coefficient of that factor to that power. So that'll be best explained by doing this example. First factor is 1/2. That is the leading coefficient of that first factor, so I do 1/2. I multiply that by the leading factor of the next factor. I'm sorry, the leading coefficient of the next factor. So this is, my leading coefficient of this factor is 2x squared, but since this has an exponent, I raise that to the power of 2. So I take the whole term, so that's the leading term. I think I might have been saying that wrong. And I raise it to the power of 2. And again, that comes from the leading term of my second factor is 2x squared, and I raise it to the power of 2 since that second factor is raised to the power of 2. The leading term in the third factor is x squared, and there is no exponent, so I can just do x squared. And now I just multiply all of these together, and this will actually tell me what the leading coefficient of f of x is if I was to put it into standard form. First, I'm just going to do 2x squared squared. So that's going to be 2 squared is 4. X squared squared is x to the 4th. And so again, I'm just simplifying 2x squared. I'm squaring 2x squared, and this is what I get. And then multiplying everything together, I end up with 2 x to the 6th. 1/2 of 4 is 2. X to the 4th times x to the 2nd is x to the 6th. All right, so what does this tell me? Well, if we want to find the turning points, what's the maximum turning points of a graph, we want to find the degree of the function first. The degree of f of x is going to be equal to the exponent of my leading coefficient. So my degree of f of x is actually equal to 6. That means that the maximum number of turning points will be 1 less than 6. And so that'll be 6 minus 1, which is 5. So there are, let me just there are at most 5 turning points in the graph of f of x. So that is part C. Part D, we're going to figure out what's the end behavior. In other words, as x goes to negative infinity and x goes to positive infinity, where does f of x go? Does it go to positive infinity or negative infinity? On the left and on the right. Okay, so again, the real key to that is to note that the leading coefficient is 2x to the 6th. Now, note that this is positive. My coefficient is positive, and my exponent is even. From that information, I know that my graph is going to have the same end behavior as the graph of x squared, which looks like this. So what that means is on the left it goes to positive infinity, and on the right it goes to positive infinity. Now the way we express this mathematically is as x approaches negative infinity, in other words, as we go to the left on the graph, f of x goes up to positive infinity. F of x goes to infinity. As x goes to positive infinity, in other words, as we go to the right on this graph, I know that f of x will continue to go up towards positive infinity. And we are done with this problem. Now, let's double check all of our answers by graphing this. So we're going to do 1/2 2x squared plus 9 squared, and then x squared plus 7. If I'm not mistaken, let me double check. That's from memory. That is correct. Okay. Now, where is the graph? I feel like it's not showing up. All right, let me try this again. From the beginning, I'm going to just reset this and re-enter this. Okay. Maybe it's way up in the sky somewhere, or maybe it's... Yep, that's exactly what happened. So notice it does not cross the x-axis. Okay. It has no x-intercepts. It has no real zeros. The amount of turning points that we can see, it looks like there's just one turning point. Now, we predicted that there would be at most 5 turning points, and in fact, it seems most likely that there's really only one turning point. Maybe if we zoom out, it dips again, but it really looks like that's not going to happen as we go on up and up and up. Okay. All right. Let's see what else. And we predicted that on the left and the right of our graph, it would go to positive infinity, and indeed, that is true. Okay. So that is how you can tell when you have a polynomial in factored form. You can get a lot of information about the graph of that polynomial. All right, hope that was helpful, and we will see you in the next video.